Hello, Algebra 2. How are you doing? Hopefully well. This is the second week and it's the second assignment, so it is 2.2. I decided that we're going to continue solving logarithm equations. We'll move on probably next week. We're going to throw in just a slightly harder question. You can totally do it, but just for this week, we're just solving logarithm equations. That's what we're focusing on, and this is the last section of solving for logarithm equations. So I've got 3 examples for you that are going to help, and then I'm going to assign 4 more problems that are very similar to the ones in the video. Let's get started. This one here, I've got solve for x. Log base 8 of 3x plus 1 equals log base 8 of x plus 15. Here, check it out. I have same bases, and we talked about if we have logarithms on both sides, like we do here, and we have the same bases, that means that these insides have to be equal as well. So I can just set these equal to each other and say 3x plus 1 has to be equal to x plus 15, and then I can just solve for x right now. So I'm just going to minus x from both sides to get x on just one side, to get our variable on one side. That's going to be left with 2x plus 1 equals 15 minus 1 from both sides. And then divide by 2, x is equal to 7. Not too bad, not too bad. All right. It's this last one that's going to be a little bit trickier, but we can do it. So solve for x. I have log base 3 of x plus 10 equals 4. So we need to make sure that we can simplify down to get the most basic, a very simple logarithm equation. And there's nothing we have to do here because it already is just a very simple logarithm equation. So my next step is I'm going to write this as an exponential equation, being able to go back and forth between those two forms. So my logarithm as an exponential equation, I have a base of 3. I know 3 raised to the power of 4 has to be equal to this x plus 10 here. So I'm going to write that. I'm going to write 3 raised to the power of 4 has to be equal to x plus 10. And now I can just solve for x. I'm going to take care of my exponent first, this 3 to the power of 4. So 3 to the 4th power, 3 times 3 times 3 times 3. It's going to get you 81. And then I have 81 equals x plus 10 minus 10 from both sides. And then you're going to be left with x equals 71. All right. Not too bad, not too bad. These are very similar to the ones from 2.1. Also, there's going to be a couple on the homework that are going to be very similar to this. All right. Let's get to this last one that I have that is going to be a little bit trickier, and this is going to be very similar to the 4th one in the homework as well, all right? It's going to use a little bit of quadratics and solving for quadratics, possibly the quadratic formula. So, solve for x. I have log base 6 of x plus log base 6 of x plus 5 equals 1. This is not a simple logarithm equation because I've got like 2 logs here, so I'm going to try and simplify this to just one basic one. I do see that I have the same bases, and I know that I'm adding these logarithm expressions, and when I add logarithm expressions with the same base, then that really means I'm kind of multiplying these insides here. We've talked about that before with our logarithm properties. So I can take these and simplify it down to one expression, log base 6. I keep that same base of 6, but then I just multiply the insides. So I'm going to multiply x multiplied by x plus 5, all right? And again, that just comes from right here, and this part comes from right there, and then I still have equal to 1. Now I can keep going. I'm going to say log base 6 of, if I simplify this inside, I'm really doing like the distributive property with this x on the outside. So I'm going to distribute the x to both terms inside of the parentheses. So that's going to become x squared plus 5x equals 1. Now I can just, I mean, this is a very simple, I mean, it looks complicated, right? But there's nothing else that we have to do to simplify it more. Now I can just take this logarithm equation and write it as an exponential. It may look a little tricky, but it won't be too bad, all right? So I'm going to do the same thing that we did. I have a base of 6, 6 raised to the 1st power. So I'm going to write 6 to the 1st power has to be equal to this inside part. So 6 to the first power equals x squared plus 5x. And then I can just start to solve for x. And I see that exponent of 2, that makes it a parabola, right? This is our quadratic. Maybe a little bit harder to solve, but we can do it. So I'm just gonna set this all equal to 0. So to get this into standard form, I'm going to minus 6 from both sides, because 6 to the first power is just 6, right? So I'm gonna minus 6 from both sides, and that's going to give me 0 equals x squared plus 5x minus 6. And now I just have a quadratic that I can solve. You could use the quadratic formula, the x equals negative b plus or minus square root, all that good stuff. Or I could just say, are there two numbers that multiply to be negative 6, but add to be 5? And yes, there are. It's just a simple factoring here. I can factor this entire thing out. So I got 0 equals x minus 1 times x plus 6. Okay, if you FOIL all of this out, you will get that parabola of x squared plus 5x minus 6. So I was able to factor my quadratic into these two linear factors here, and now I can see some answers, right? What would make this part 0? Well, if I set that equal to 0, and I solve for x, add 1 to both sides, I'm going to get that x equals 1, right? It's kind of like the opposite what's in here. So I have one solution of x equals 1. And what would make this side 0? Well, let me just set that equal to 0. X plus 6 equals 0. Solve for x. I'm going to have x equals negative 6. Here's my other solution here. All right? And the trick with these guys, we want to check to make sure we don't have any extraneous solutions. Remember when we were solving nth roots and quadratics and whatever, and sometimes we came up with 2 solutions. I think that was back in chapter 8? 7? I can't remember. That was a long time ago. Anyway, we always had to always plug your answer back into the original equation and check to make sure it made sense or not. So I'm going to go back to my original equation. I'm going to write it down at the bottom real quick. So log base 6 of x plus log base 6 of x plus 5 equals 1. Okay, that's our original equation right here. And I'm going to check both of these solutions in my equation. Make sure they make sense. Let's use blue. So I'm going to check. This is my check of x equals 1. All right, so I'm going to check this first one right here. I'm going to plug x equals 1 into my equation. I'm going to have log base 6 of 1. So instead of x, now I'm going to put in a 1. Plus log base 6 of 1 plus 5 equals 1. All right, let's just kind of work through this here. Log base 6 of 1. What power? So I'm just going to kind of look at this logarithm expression and evaluate it down. Basically, it's saying, what power do I need to raise 6 to in order to get 1? Well, 1 is smaller, so I can't really, make it bigger. What about 0? Because anything to the power of 0 is 1. So if I have log base 6 of 1, I would have to raise 6 to the power of 0 in order to get it to be 1. So this logarithm expression just evaluates down to 0. Plus, okay, let's look at this part now. And this is going to be, okay, I'm just going to simplify the inside and say that's just 6, right? So this is going to be log base 6 of 6 equals 1. Okay, now let's look at this. What power would I have to raise 6 to in order to get 6? Well, nothing changed, right? It's still just 6, so I would just have to raise it to the first power. So I've got 0 plus this thing all the way evaluates down to just 1 because 6 raised to the first power is just 6. So I got 0 plus 1 equals 1. Oh my gosh. Does 1 plus 0 equal 1? Yes, it does. I get that 1 equals 1. That's a true statement. It makes sense. We're good to go. So I know for sure that 1 is a solution. Let's check negative 6 real quick. So I'm going to check -6. I'm going to use the green. Okay, so here is my check of x equals -6. I'm going to plug that in. Log base 6 of -6 plus log base 6 of -6 plus 5 equals 1. Okay, let's try and work this out, see what we get. Maybe we'll get a true statement. Maybe we'll get something that doesn't really make any sense. Okay, I'm going to look at this first part. Oh, it keeps flipping to eraser. I'm going to look at this first part here and say, okay, what power, let's try and evaluate this expression down, this log base 6 of -6. What power would I need to raise 6 to in order to get -6? Well, you can't really raise a positive base. I can't raise a positive base to any power and have it give me, and have it give an output of a negative number, right? It just doesn't really work. You can't, there's no number. So this technically is undefined, and I'll show you here in just a second what I'm talking about. So if there's like an undefined solution, right, I don't even need to continue going because already we've ran into this roadblock of you can't raise a positive base to some power and get a negative number. It's just not going to work. So x equals -6, I'm just going to toss that solution out and say, can't really happen. All right? So I know I've checked x equals 1, and that has to be my solution. I'm going to make it really clear. Here we go. Ready? X equals 1. So cool. Hang on. I am going to bring up Desmos, and we're going to look at this real quick. Okay. What I have graphed over here is the function that we just looked at. So I kind of just dropped the equals 1 on the end, and I just turned this into a function. So the red line, this red line here, shows the function log base 6 of x plus log base 6 of x plus 5. And what I'm going to do is I'm going to graph both of my solutions that I came up with, the x plus 1 and the x equals -6. If I graph x equals 1, I turn that line on and look right here. I do have a solution between these two lines, right? Between these two functions, these two curves. They intersect somewhere. There is a solution to like that system, right? So x equals 1 has to work. If I turn that off, and if I turn on the solution of x equals 6, which we found, I'm going to turn that on. And there's my line over here, this x equals 6. Does it ever touch that line? No, I keep backing this out, and the red line and the black line, they never touch each other, right? There is no solution, and Desmos kind of freaks out eventually here. Ooh, it's really glitching. There's no solution to that system, right? So now I can see that x equals -6. It never crosses my logarithm function. There's never a point where it makes this function true. So x equals 6 is just like an extraneous solution. It's not the solution. We're only looking at x equals 1. Again, whoops. Again, we can see that. There it is, that intersection at 1, 1. When x equals 1, y equals 1, and that's what we saw here. When we had an x value that we plugged in for 1, we plugged in x equals 1 into here, then our y was also 1. All right. That was kind of a lot, but I believe in you. I believe in you. So you will be given, especially on the homework on number 4. Okay, it's going to be kind of similar to this. You're going to be given a function. You're going to have to use some logarithm operations to simplify. Once you write it in an exponential form, as we did here, you're going to have to put it into standard form and see if you can factor something here. All right. Please let me know if you have any questions. Again, I have 4 questions, continuing solving logarithm functions, and they follow very similar to this video, as well as the video from Tuesday or the assignment 2.1. Let me see. Was there anything I needed to talk about? I don't think so. If you're not part of the Google Classroom chat room and you want to be, you have to go to, because as soon as you emailed me, yes, I want to be on it, I went and automatically put you on the list. You have to go look at Google Chats, which if you go to the like waffle board in the top right hand corner where you usually pull down like Gmail or Google Drive or whatever, if you hit that and you kind of look for an icon that looks like an @ sign, that looks like an @ sign like that, you'll get Google Chats. And there should be an invitation sitting there. Hey, come join Algebra II 4th period chat room. And then you can answer questions and ask questions, and there's a couple other things that we've talked about problem-wise. So, all right, have a great day, and I will see you later. Bye.